Good afternoon, everyone. I've got everything typed out. It's hard to type and teach at the same time. I'm finding that out. With Microsoft Word, it's just about impossible because Word is so laggy that it makes concentration next to impossible due to the lag. Now, uh, many of you have already, or a few of you have already moved on to the optimal value problem, and this is number 20 on chapter 4 for my finite math people. And I'm addressing my finite math people. So this is number 20 on chapter 4. Now, first, I want to optimize the how can my protagonist or my person in my row optimize his or her strategy. So let's say that we're given the matrix -2, -3, -5, and +4. How can he or she, my protagonist, which is my row person, optimize his or her strategy? So we can think of the row person as sort of the protagonist, if you like, and of the game, and the column person as the antagonist. And this is a zero-sum game. If you win, your opponent loses, and that's that. If you lose, your opponent wins. There's no in between, there's no trade off, there's no complications. You either win and your opponent loses, or vice versa. That's called a zero-sum game. Um, so, um, there's no fancy tricks or anything. So the way we play this is, well, you for if we're the row person, optimize the row's winnings, um, or I should say the row player's winnings. So, and we'll say that's the protagonist, the role player. So and since we're focusing on the role player, that's where we put our variable. Okay, so the person you're focusing on is where you put your variable. Now the person you're kind of putting on the shelf is where you put your zeros and ones. So first you do your 1 0, and then you do your 0 1. So here's the way it goes. We do x1 minus x, and you put the 1 0 here for your antagonist. Okay. We have to assume that the antagonist is going to play his or her best game because they're not going to let up, right? They're going to absolutely try to give it their best shot, right? They're not going to slack on us, right? So they're going to play well, you know. So we stick a 1 0 here. Now for us, we don't know. We're going to stick an x and a 1 minus x here, and now we go through the matrix multiplication by associativity. Now remember, with matrices, associativity is still good. We don't have commutativity anymore, but we still have associativity and distributivity. So we can enjoy those properties. With this one, I think we mainly use associativity. So I'm going to save this one for a little later. You can go ahead and do this first if you want to. I went ahead and did this guy and this guy first. But you go ahead and just do this matrix product here. Remember how to do matrix products. You go row by column. You go 2 times 1, -3 times 0. -2 times 1, and then -3 times 0, like this. And then you PEMDAS. But -2 times 1 is -2, plus 3 times 0 is just 0. So you do, again, by matrix multiplication, you go like this across and then down, where the -2 1 product plus the -3 0 product. That's how you do. It's like a covector and goes down the vector. And then this covector -5 +4 goes down the main vector 1 0, and you get this. Okay. Now you go through the process, you'll get -2, -5. Okay. But now we got this covector, which consists of the variables, x 1 minus x, and then you got neg 2, neg 5, and you go through the. Now, guys, a covector in front of a vector always gives just a 1 by 1 matrix, which you can just associate with a number. Well, 1 by 1 matrix, it's not really a number, but it can be quote unquote associated with a number. But there's still at the end of the day, there's still the brace that's wrapped around it. But anyway, or the parenthesis or whatever, because it's still a 1 by 1. But so here we go. But anyway, let's do this. We got this times this, and now indeed a 1 by 2 times a 2 by 1 is a 1 by 1. And we go through the motions. X hits the neg 2. The 1 minus x hits the neg 5 by because we row by column. So x hits the neg 2. 1 minus x hits the neg 5. So we get neg 2x. Now the neg 5 distributes through 1 minus x. Now neg 5 neg x gives plus 5x. Neg 5 1 gives minus 5. And we get parentheses 1 by 1, the 3x minus 5. But guys, we can just yank out the 3x minus 5, so the entry that we want. Oops, that's a typo. Sorry, guys. So the entry inside the 1 by 1 matrix is 3x minus 5. I had a little typo there. Sorry about that. So analogously, and let me just put sorry for the typo. Now analogously, and I fixed it. Now, analogously, we do x, 1 minus x, and then neg 2, neg 3, neg 5, 4, going down 0, 1. Now, I take advantage of associativity, and I do the same old 1, 2, 1, 2, and I go through the motions. Let me stay still a minute where you can see the stuff. So you can hit pause and write all this down. Neg 2 times 0 plus neg 3 times 1, that is neg 3. And neg 5 times 0 plus 4 times 1, that's 4. And then I do the covector x 1 minus x times the main vector neg 3, 4. And you're going to wind up with this, but that winds up being just the 1 by 1 matrix, just the 1 by 1 matrix, neg 7 plus 4. And that's just what you can call the trivial matrix, which you can just associate that with just a single term, neg 7x plus 4. But then you set these two things equal, you'll wind up with 9/10. And guys, I have to type this out before I talk, or I'll make 100 arithmetic mistakes, maybe more. Now, so there's x, but once you have x, and I'm gonna let y. I'm just going to say that y equals. Let me just say. Let me denote. I'm going to define y. I need to define my y because it's just natural for me to define y to be 1 minus x. It's my y coordinate, So y equals 1 minus x, but we've already determined x to be 9/10, so I do substitution. And then, but now 1 minus 9/10 is 10/10 minus 9/10, common denominator, and that's 1/10, and there I go. So there's my stuff. So there's my optimal strategy. For my row guy. Now I need to for the opponent, I need to do him or her, my column person, the antagonist. So I put 1, 0 in for the protagonist, the row guy, which is the covector. Now my antagonist is the column vector here. And guys, I do associativity. You could do, if you wanted to, if you're a left or right kind of person, you can always do that. You can always just do these two first. But for some reason, I was in an associative mood, but I went ahead and did these two. And you just do row by column, neg 2 times x, and then neg 3 distributes across 1 minus x. So we get neg 2x, and that's plus 3x minus 3. Because neg 3 neg x is plus 3x. And neg 3 plus 1 is minus 3, okay? So, and then likewise, we go across this row, and it's going to hit the downward column. We get neg 5x, and then plus 4 distributed across 1 minus x. But that's plus 4 minus 4x. And since 4 is positive, we don't change the signs. Whereas 3 was negative, and neg 3 was negative, and we did change the signs here. Anyway, so if we go to the, up here on this second page, well, we get, well, we just go through, we get our stuff. What do we have down here? Now, guys, neg 5 and neg 5x and neg 4x, we had like terms. We can't do much with the plus 4, but now neg 4x and neg 5x give us neg 9x. So we have neg 9x plus 4. And now neg 2x plus 3x is plus 1x, which is just x. And then the minus 3 can't do much with it. So it's 1x minus 3, but that's just x minus 3. So here's our stuff. And we put that in front of our covector. Now, remember, guys, these don't commute. I should have told you, and that the same thing was true of our stuff way up, we did 6 minutes ago. No, you can't commute stuff. We can associate all day, but we can't commute. And nor could we have commuted earlier. Back when we were doing our stuff a long time ago, we could not have commuted there either. So commutativity is off limits. So just keep, you got to keep what's in front stays in front, what's in back stays in back. You can't go moving stuff. You can't put this in front of this. But anyway, 1, 0 times this. But now 1 times this is this. And then, but 0 times this is just gone. So this, 1 times this plus 0 times this. But, subliminally, we got a plus sign and we got 0 times. And then, but guys, it didn't really amount to a hill of beans because it's all gone. That 0 just washes away that neg 9x plus 4. And it didn't amount to anything. Now, if that were not a 0, if that were like a 2, I would have like plus 2. And then if this were a 2, I would have minus 18x plus 8. And it would matter greatly. But 0 just annihilates this guy. So I just have x minus 3. And, but anyway, I don't guess I need to worry about hypotheticals. So here we go. But now, remember, similarly, just like we did with the protagonist, with the antagonist, I need to do 0, 1 here. And then my same old guy here for my, well, I need to put 0, 1 for my since we're considering the antagonist, I need to put 0, 1 here for my other guy, which is my protagonist. So and again, just as before, we keep our, in analogous fashion, we keep our antagonist the same. You always keep x in front of 1 minus x. You don't trade places with x and 1 minus x, but you do trade places with the 0 and 1. Again, guys, just to reiterate, and just so this is clear, we do trade places when we change the cases around. We do trade places with the 0 and 1, yes, when I do my next consideration, but I don't trade places with the x and 1 minus x, okay? That'll get you in trouble, okay? But anyway, keep x in front of 1 minus x, or in this case, I should say keep it above it. So here we go. This right here is just like it was before, and I want it that way. So we go through the motions. And you just go through the same old algebra. And you wind up with 4 minus 9x. And I'll scroll slow so you can see the stuff. I did associativity again. I ended up with this. So I went from here to here. Then I ended up here. Then I ended up here. And I ended up with the 1. And finally, I ended up with the 1 by 1 matrix 4 minus 9x. Okay. But then, you're going to get, well, here's the final answer, but how do we get there? Well, I don't want to jump there yet. So, plot spoiler, but anyway, so we set the x minus 3 that we got 3 minutes ago and to the 4 minus 9x that we got right now. And then you'll end up with rearrange, you'll get 10x equals 7, and you'll get x equals 7/10. We're just doing for the antagonist what we did for the protagonist. So we get, so the antagonist being the column guy. So we get x equals 7/10, but then my y coordinate, well, if that's true, then my y guy is going to be 3/10. My y guy is 1 minus x. Guys, these are like probabilities. If you have a 7/10 chance of probability of winning, you got a 3/10 probability of losing. But anyway, so there's that. Now let me set C up here. Now C, what is, they're asking me for the expected value. So so we've got all this. So we've got our we got a row guy a long time ago. We just now got our column guy. So what's the expected value? Well, you plug 9/10 and 1/10 that we got a long time ago in for the row guy. Those were his or her numbers. And then for our column lady or guy, we got these are the column numbers that we just got, and then put the main matrix in the middle. Now you can't change the ordering. You are not allowed to change the ordering. You must put them in this order. You don't have commutativity. Like you can't go putting this over here. That's wrong. You can't do it in this order. In this order. So and then you'll let's see. What did I do? I did not do associativity. I actually went left to right. So I did the first two first. So I just didn't. I decided you could do the associative route and do these two first. You have associativity. You could multiply these two first if you wanted to. You could, and you'd get a vector. But I went ahead and did covector times matrix, which gave me another covector. Okay, and so if you ever do matrix vector, you'll get a vector. But anyway, so I went the other way. So here's my covector times my vector, but that's just going to give a pure number. Well, it's going to give a pure 1 by 1, which might as well be a pure number. So I do covector times vector, and that's just going to pretty much give me a number, which is just a 1 by 1. But so my expected value is negative 23/10. And that agrees with I used the book to get this. So the book agrees with me. You'll get negative 230 over neg 230 over 100, but you can reduce, and that reduces to neg 23 over 10. And that's that. That's the expected value. So that means that the column, the antagonist can expect to win on average negative 2.3 whatever. If these were in dollars, the column antagonist can expect to win $2.30 on average, and our protagonist would lose on average $2.30 a game. Now that's on average. That doesn't mean that's going to happen like robotically every game. You know, this is an average, right? So this is the expected payoff. Now, if we're the protagonist, if we're the row person, and our expected value is bad and it's rotten, and negative means if our expected value is negative for us, if we're the protagonist row guy or lady, and if well, that means we don't want to play long. See, the column person would probably be the casino, and they probably would like us to stay there all day. Now that we can win games, like that doesn't mean we can't win a game. We can win several games. We may even have a big game that we'll win. But if we were to stay for a long time, we would eventually start to lose because our expected value is negative. That means if we were to play many games, on average, we would lose negative 2.3. We would lose $2.30 on average each game. But anyway. Let me see. I think it's pretty good. This is the best way to do it. It's not the shortest way, but the other way forces you to memorize generic formulas, and I don't really care for it. And I don't really want to go neck deep into 4.4, but I wanted to get this part out. Let me go ahead and just load this video. Thanks, guys.